Hello there. This was a question that was sent to me today, and it's such a good question that I thought I'd make a very quick video. This question is asking you about how to interpret the regression line for the exponential. So this is an exponential equation. You can see that we've got A here, that's the intercept, and then B is the other thing you'd be asked to interpret. X is your variable and Y is your other variable. So they're the things that we're looking at. Our independent variable, our dependent variable, our y-intercept, and this is the percentage change, whether increase or decrease, as our independent variable increases by 1 unit each time. So let's have a look at an example. So imagine we're doing our assignment and we get this regression line that t, or let's go approximately, equals 98 times, say 1.05 to the power of t. So here you can see my variable t is the time in minutes, and the capital T here is the temperature. So if you were to interpret this, what's been pointed out here is that the A is the y-intercept. So here we would say that the y-intercept, that's when T is equal to 0. So when the time is 0, the capital T, or the temperature, is 98 degrees Celsius. So that's how, and we interpret that in context. So looking at this part here, how to interpret the B, what you do is you look at the B and you go, that's 1.05. So let's think about it in terms of a percentage. That would be 105%. So if I've got 105%, what I do is I find the difference between that and 100, and that gives me 5%. Now, because this number was over 100, this represents an increase. So when we look at this graph, for every 1 it increases on the independent axis, so for every 1 in time, every 1 minute, it's saying that this increases by 5%. So for every 1 unit, it increases by 5%. That's how you interpret that first equation. Now let's look at this example here. So I've got a different exponential regression line here, and if you want to interpret this one, here's my A value is 97, so that's my y-intercept. So that's saying when the time is 0, or at the start of this experiment, then the initial temperature is 97 degrees Celsius, and that's given you the answer in context. Now to interpret B, here B is 0.12, so think of it as a percentage, times it by 100, that gives me 12%. Now this is less than 100. This one over here was greater than 100, so I took my 105 and I took 100% from it, leaving me with 5%. This one I have 12%, which is smaller than 100, so I find the difference between that and 100, and what does that give me? That gives me 8, brings me to 20, so it gives me 88%. Sorry, I'm just running out of space. So B here represents the change. So when I am graphing, this is a decreasing function because it's smaller than 100. So for every 1 step, or every 1 unit on this axis here, what is happening is this function is decreasing by 88% each time. And that's how I interpret the B here. So for the first one, I interpret B by saying 5%, it's 5%. So for every time T goes up by 1, the capital T increases by 5%. The second one here is telling me every time T goes up by 1, the capital T decreases by 88%.